I think the challenges we face are obvious. It's emissions, it's the limited resources for fossil fuels, it's also chaotic transport situation or traffic situation, especially in megacities, which needs to be solved. And despite all these problems, we actually need to provide mobility, especially cost-effective mobility for emerging countries. So, in our point of view, what are the fields of action? First of all, and with highest priority, we need to make engines and drivetrains more efficient. The drivetrain technologies, we believe, must be optimized according to regional specific site conditions. We definitely need to look for alternative drivetrain concepts, especially to enable us to access alternative fuels, get away from petroleum in the long run. And another factor that's often forgotten, but that definitely can contribute, is optimizing traffic management and infrastructure measures, things like intelligent transportation systems. Now coming to the one question that has been posed before and addressing the argument of how to increase efficiency. The greatest potential for efficiency increasement definitely is working on the drivetrain, but one must not forget the weight of the car. This can contribute significantly too. We've shown that in the Audi group. Here you see some figures of what can be done by introducing aluminum bodies. Admittedly, this is something expensive, and it is until today limited to the premium market due to this high cost, but the effects can be seen. And there are similar measures, not by using aluminum, but by using an intelligent mix of steel-based, high-strength steels, for example, which can also be introduced in the volume market for more cost-sensitive car segments, as we have shown, for example, on the Passat limousine. Now, coming to the drivetrain, what can be done with conventional technologies that are available today? Please allow me to give a few examples there. One example is fairly simple measures like working on the gear train, low resistance tires, some aerodynamic measures, and by these fairly simple measures, as you can see in this blue motion fleet, as we call it at Volkswagen, in the blue figures you see a comparison with the conventional vehicle. You can see that you can achieve a significant decrease in fuel consumption, and this is a low-cost approach, and it can be implemented very fast, so you have fast realization times. A more advanced way is introducing new technologies, also in the drivetrain, for example, introducing a new transmission technology like the double-clutch transmission, which for the customer is in the same price range as conventional transmissions, but as you can see in the figure below, allows you to decrease fuel consumption significantly. You can even, not only below a conventional automatic transmission, but you can also, you can even achieve values below that of a manual switched vehicle. On the motor side, we see a great potential with turbocharging, which has a long tradition on diesels, but if you do turbocharging on gasoline engines and accompany it with so-called downsizing concepts, you can see on this one chart what can be achieved there, and this correlates with the one figure you have shown. You can even achieve better performance of the engine or the car in terms of dynamic, but at the same time decrease fuel consumption. Looking more in the future, here you see a very rough roadmap for diesel and gasoline engines. There are several parallels. The diesel engine is tuned into becoming more clean and becoming even more efficient. Same on the gasoline side. And we see that the two engine concepts grow together. And eventually we see an engine family, which in the Volkswagen Group we call CCS, for combined combustion system, which includes both advantages, clean emissions and low consumption, but which must be accompanied by a new type of fuel. This again is a chance for synthesized fuel, and especially BTL type fuels. And if you introduce concepts like this, you cannot only achieve better and more efficient engines through engine modifications, but gain an additional advantage through this combination with new types of fuels. In this chart, I want to get back to a more fundamental look at the problems we are facing. Here you see a coordinate system where on one side you see well-to-wheel CO2 emissions for different drivetrain concepts, and on the x-axis, on the horizontal axis, the energy demands to propel a car of the Golf class, a medium-sized car. You see the yellow and the red bubbles reflecting the present state of the art for gasoline and diesel engines. And if we now look into alternative drivetrain concepts, the blue dots give values for fuel cell vehicles, hydrogen-based fuel cell vehicles. And you see that depending on how you create the hydrogen, fuel cells are not really the promising solution for the future. You lose both on the energy equation and on the well-to-wheel CO2 emissions. Neither way really gives you a definite advantage compared to good technology today. So that's, in our opinion, not the real solution for the long-range future. Very promising, obviously, is introducing biofuels. That's the green bubble on the lower right. But you achieve very low CO2 emissions, but you pay that with an increased demand for energy. So this might contribute, but it's also not the silver bullet solution. And on the other side, we see this red dot for electrical drivetrains, which is quite interesting in every respect, because you have an access to new energy carriers, energy sources, and even with today's European power mix in the electric grid, you achieve better efficiency and better well-to-wheel CO2 emissions on the road. I'll come back to that. Biomass. Biofuels definitely can... Sorry? Can we go back one? Okay. Biofuels definitely can contribute, but as has been said before, it's not the silver bullet. They can only contribute something like 10 to 20%, as we believe, and very essential will be the question of how biofuels will be created. We definitely believe that the only reasonable solution is biofuels of the second generation, which means BTL or cellulosic ethanol, which requires that we definitely get some regulations, certified regulations on how this biomass is created and converted into fuels. We also need to get access to other types of fuels, even if they may be fossil. We see there's a limited but good market for natural gas. And if you combine that with new drivetrain and engine technologies like this TSI turbocharging, then you get very good emissions values and even very good energy or energy demand values for natural gas drivetrains. This Passat CNG that we are just introducing is a very good example for this technology. I've already mentioned my opinion on the real chances of hydrogen-based fuel cells. We are working on that too, but the main question is, where's the hydrogen coming from? How is it generated, from regenerative sources or somewhere else? No matter how you create it, the efficiency factor is not very good, because you are always transferring energy carriers and you lose a lot of primary energy, which is scarce and will become even more expensive in the future. So the real promising future there is in electrical drivetrains. We believe there is a true chance for plug-in hybrids. True electric drivetrains will be a very long-range solution, because the critical component in these drivetrains definitely is the battery. It has low energy density, it is very expensive, and the technology is very new. So no matter how promising the principal discussion on efficiency looks, it will be a long way. It will demand a long time till we have true electric drives on the road. And the speed of this conversion will mainly be driven by progress in battery technology. This shows, the bubble shows some generations in terms of, measured in terms of energy density that we see will evolve in the next decade for battery technologies. And you can see that even with an optimal look at it, if we should reach 200 watt-hours per kilogram, you can create cars which might achieve a range of something like 150 kilometers, which is not really competitive to today's cars. So the way this technology will be implemented will most likely not be the true electric car, but rather something like plug-in hybrids. And my last point is that since we don't have the silver bullet, you must look into every potential that's available. And another significant potential can also be derived from an optimized traffic management and infrastructure measures, or as it is often called, intelligent transport systems. So far for my contribution. Thank you very much.